Hi guys and welcome. Welcome to my office and my very improvised shades for the computer screen. So today we're talking about 5 really important questions. So these are the questions that I get the most and I think that are most confusing for people around the world. What are solids? So the solid models everyone's talking about. What are surface models? Surface models that people are talking about. And of course triangulated mesh or mesh models that are really common on Thingiverse, for example, where you have STL files, which are in mesh formats. More on that later. The first question is, which one is best? Well, you have to see the whole movie to try to get an overview about that, because it's not really that simple. And of course, number 5, how do I convert between one format to another? We're going to briefly touch on the subject, but it's a really complicated subject and there's a lot of examples that needs to be shown. But I'll try to do my best to go through, first of all, what are the different formats, where do you use them, why are they good, and also leading into the question which one is best. So we're going to compare them to each other for general use. And of course, show you some tools how you can convert or how you can make it easier for you to jump from one format to another. So I think that's all for the intro. Let's roll the clip. So, a solid model is separate from other file formats by its emphasis on physical fidelity. This means that it has a geometric and solid, it's created by a geometric and solid modeling form. So this example shows a little bit what it is. It's a shape defined within a 3-dimensional space. So I'm going to show you next up a little bit how we can use that, so you might understand what a solid is a little bit better. So let's head over to Fusion 360 and start modeling with solids. I'm going to use the Autodesk Fusion 360, my favorite software for solids. So I defined the first measurements here of the box here. So the whole idea of a solid is that we're creating a new body here. I'm going to add here 50 millimeters. So I'm creating a perfect box and click OK. So the thing with this, a solid, is that I can still select these surfaces. So a solid is it's a volume, but it also has surface elements of it. So the thing with solids is that it's really nice that you can, for example, I can create a new cylinder on top of this surface. I'm going to create a diameter of 20 millimeters. And now when I'm using solids here, I can actually cut through things. So I can drag this down, let's say 20 millimeters, 25, halfway, sorry, minus 25. So you can see here that the operation that I'm doing right now can either cut away, or I can also join this, so it creates a new type of model. So let's start off with cutting, because that's pretty cool. So now I've cut through this model and it treats the inside as a volume. I don't have any weird geometry anywhere and stuff like that. So what I can do here, for example, is to go back and change. So I can go in here and change the parameters. So let's say for the box here, so I can change that this value wasn't supposed to be 100, I wanted it to be a 500, for example. Now that's a little bit much, but let's say 60 instead. So we still have the same model here, as you can see, but it's now 60 millimeters long instead. And I can change here the diameter of the, see here the diameter, I want to have it, let's say 15 instead. So I'm just making the hole smaller. So by using solids and parametric solids, I can start to edit things much more clearly. And for example, just adding something like this, a little fillet, that's really tricky to do on a, let's say, a polygon model.
Usually you can do it on surface models as well, but that's really one of the strengths with the solid tools. So let's check out an example of how you can use the solid tools. So I have here let's see here, here's your camera rig. So solids can be really good to create mechanical parts that aren't really, how should I say it, there's no organic shapes in here. Now this model is like over designed, so I've made way too many chamfers and different measurements here to just add details and try to add strength while keeping the material down. This part is made for 3D printing, and so you can see here that I can select, for example, this surface here. I can press pull it, I can make it bigger, larger. You can see that everything follows. So that's really nice with the parametric models, and of course I can reach a maximum somewhere. But you see the way that it treats the model, that it represents a solid volume, and we have more or less a Boolean operation. So you have plus minus that keeps subtracting mass from the model, more or less. So I think that's a good representation of what solids are. I will show you more what surfaces next up, and hopefully that will give you a bit more separations between the two formats. So solids for engineering, for mechanical models, for more constructional design. And let's jump over to surface models. So a surface model, so what's different from a solid? Well, the whole idea is that you work with tangents and a surface, and you create a shape between that. So you can see here this really good example that you draw the shape and you add some details to control the curvatures. But the whole idea is that you have control points, control polygons, and you make smooth, organic type models. So you see this here, for example, it consists of a few radiuses, and this would be very complicated to create with a solid defining these type of curvatures. So that's what a surface model is. I will show you a little bit of why you use it, how you use it. Okay, so I have my solid left here. So still within Fusion 360, I can choose now to create a form instead. So now form is more of a surface model, which enables me to create, let's say, a box here again. So I'm going to do the same measurements here, 50 by 50. And it doesn't really look like a box anymore. So this is due to this actually now consisting of edges, of points, and surfaces within the form. So what I can do if I want to is I can click here on Finish Form. So I'm just going to do that. So you can see now it's transformed into a solid. So I can now start, let's say here, cutting away with the cylinder again. Now it's a little bit more tricky here, since I can't always just click on the things that I want to. So you see now that it transformed the box to a form. But anyway, let's create a new form here. So I'm just going to do something over here. Let's say 50 by 50 again. Oops. Like so. So now the interesting things with forms are that I'm stuck within the form tool right now. So if I want to jump out and do something else, I need to click on Finish Form. I can always just click back here to join at the history again. So the thing here, I've chosen some of the tools here. There's a lot of things that you can do, but I have my favorites up here. I will show you shortly why I have these specific tools. These are the ones that I use for the kind of things that I like to do. So edit form is the basic one, so you need to click on that, and then I can start to transform this. So I will select both of those. I can now start to drag the form away. So you can see here how the forms actually work. So all of these surfaces here are more or less, they have a tangent within them. So the whole goal here is to control the flow of the surface. So you have on the gizmo here, or on the transformer tool, or whatever they want to call it, we have a few different things. So we can move it in, translate it in all the normal axes. Z, Y, X, and of course, yeah, sorry, Z. So that's one way you can do it. You can also rotate the surface in different directions, but you see how it twists and curls. So it's still really, it's a flow in the surface. Compared to the normal solids, you have a more mechanical, mathematical shape. Here it's very organic. Of course, everything is controlled by math, but I will talk you through how to control it, but the lines here, that's what you're supposed to focus on. So for me, when I create stuff, I really want to focus on these lines. So except for that, we also have another tool here. We can shrink and scale the shape here, more or less to put some tension on it. If I want to make a sharper edge or a longer edge, I can put some tension on it. So anyways, so you see here the curvature here. It's quite smooth. So what I can do here is to add some sharpness. I can either start to relocate the models towards each other. So tighter details of edges means sharper model. So you can see if we compare this side, it's now much sharper compared to this side. So when you have a further distance between the lines, the motion is much more smoother. So you can see when I move this up and down, it's very smooth. But as soon as I go closer to this edge, it starts to get sharper. And these, of course, can be controlled as well. But the most important part is that you can add details if you want to. So there's a bunch of tools here that I'm not even gonna go into because it's almost too much. But something I like to do is to change from the smooth mode to the box mode. It gives me a little bit more control. So I come from a polygon modeling world within 3D Studio Max, for example. So this is more normal for me to work with, where I can see the flow of the polygons, and then I click on the smooth mode, and I now get the details that I want to have. So I'm going to show you one way that I like to work with polygons. So I'm going to start up here. I'm going to load my file. So in this project, I'm drawing a Ferrari Enzo chassis on top of Daniel Norie's, let's see here, Daniel Norie, his OpenRC car. So I'm doing a few modifications, but more or less I'm creating a shell of the shapes here, which will then be cut up. So this will be converted with the solids. So when I press this tool, it converts into a solid, and I can then start to cut, add some, let's say here, screw holes for the different screws. Here, back here, for example, I can add holes here for the screws and do that much more controlled. So the idea here is I'm going to show you the tool here. So I'm going to edit the tool, go to display mode here under selection, and I want to display box instead. So now this is much more unsmoothed. So you can see here how I add details. So there's two ways of adding a sharp edge. You can either do something that is called modify crease edge. So you can see here it creates a sharp edge between faces. That's really good. I can do that on some places. So for example here, these thicker black lines are sharper compared to, let's say, this line, which is a flow. So you will see here now that we have sharp lines here. It's to define let's say a vehicle line here, but up here I don't have that, and neither do I have over there or over here. So these motions here will be smoother. So now when I click on this smooth tools, you can see that the big surfaces are still kind of undefined, but as soon as I add a little bit of details, I get a sharper edge. So see down here, for example, and of course, if we look over here again, you can see that this line is still sharp, and this one is well, but this one has a bit more flow. And as soon as I add more points, I have more control. So let's check out these lines up here as well. So you can see that it's quite sharp, this edge that I had. I'm gonna go back here. So I have 3 edges here, kind of narrow, just to define that outer edge of the vehicle. So as soon as I smooth it, you can see that it keeps that shape instead of just moving over the place, like it does here in the front. So I probably need to add some more details over here. Let's go to box mode again. You can see I don't have the same amount of edges here. let's just do a quick experiment where I add a little bit of edges here. So I'm gonna add it on that side, probably maybe something like that. So now when I smooth this again, you can see we stopped doing the edges over here. So now when I smooth this, it should be a little bit sharper. So there we go. Sorry about the transformation here. But so you can see here that this surface is still, I need to reset the zoom. So that surface is much sharper now over here, but not over here. So this is the place where I still have, you can see here the lines that have more details over here compared to over there. So this edge here is quite smooth, quite okay. This one gets a bit more sharper. So again, I can, if I want to, just remove those. Let's update a little bit. But it's really good that you can move, add and move tools. So the whole idea here is to use the surface tools because I can control it much better, control the flow of model, and of course, convert it into a solid, at least when I'm using the Fusion 360. So that's why the models here are really good too, and the surface tools are really good. So I hope that shows a little bit more what surface models are made for. They're made for these smoother results. And we should probably move over to polygons, which is more commonly used as an exporting files from solids or surface models. So let's go over to that and check that out. Okay, so what is a mesh? Well, a mesh is a polygonal mesh is a collection of verticals, edges, and faces that defines the shape of a polyhedral object in 3D computer graphics and solid modeling. Yeah, sure, solid modeling comes in as a term as well. So, as you can see here for the dolphin, it's flat surfaces, flat triangles that together define a bigger object. So you can see it as a resolution of a solid. So you define a solid by using, or you define a shape by using a resolution, much like a picture is defined by its resolution. So you have a full HD, you have 4K, and so on. So you have, the more details you have, which means, which translates to the more polygons you have, the more details you have. So another interesting thing about polygons is that if you zoom in, you will end up with a flat surface. When you have a solid or a surface model, you can zoom in indefinitely and infinitely, and you will get you won't get this barrier of resolution in the same way. Of course, a curve will still be considered almost flat, but now we're talking like pi, for example. How many triangles can you fit in a diameter and so on? No, I'm not sure if that's the mathematical term, but that's how I look at pi. Sorry, not pinship, pi. So it's almost the same thing here. So where you try to visualize how many triangles or polygons can you get within a circle. So more and more and more. And there's plenty of cool math here, but I'm not going to show you all of that. So it's almost the same thing here. You have a resolutions to explain something. So be able to explain a pillow, for example, that's incredibly difficult with a surface model or a solid model, but it's more easy to control and explain with polygons and edges. So let's see how we can work with polygon mesh. Okay, so next up are mesh formats. I'm still in Fusion 360 because I want to show you how it looks when you convert a solid or a surface model into a polygon model. So usually you see polygon or triangle models from, for example, Thingiverse, where people create their models and then export into STL file format, which they upload to Thingiverse. So in the best of worlds, people would export solids and parametric models as well to have within Thingiverse to help you reconfigure or redesign the model. Anyways, so polygon models are based off a lot of triangles and a lot of multi-polygon surfaces, so they only have a flat triangle. There's no bending involved, there's no smooth surfaces. So every radius, for example, needs to be defined by a lot of small triangles. So let's start off here by showing you how it converts or looks within Fusion 360. So I have these flat surfaces and I have this radius in here. So I'm actually going to add just a little bit of detail here to give you a better understanding. Let's do something like that. So these are just chamfer that I defined, but let's go to 3D prints, select object, make sure you have preview mesh on. So I think this is really interesting. You can now see how it converts all of the smooth surfaces are now converted into flat triangles. So this edge here is completely flat, this one is flat, and this one is flat. So over all of these model, you actually have steps, almost like the steps of a 3D print. So if you look at the 3D print, you see the layers. This is almost the same thing. So you define a curvature by having multiple steps. You can, of course, increase this. So you can go to medium and decrease the amount of triangles, or to high where you have a lot of triangles. So usually this high setting is good enough, but for some printers, let's say a Formlabs or SLA printer, where you have incredible detail, you sometimes need to adjust the settings here. So you can do a surface deviation. So that means that you can control it on how much you want to deviate. So let's say 0.012. I think that's pretty good. You can have a normal deviation as well. Maximum length of triangles. This is just to divide it into more models. You can see here that we're creating more or less just more edges here. I think that can be pretty good sometimes, just to have a better flow. You see here how everything is connected and it's only consists of different triangles. Aspect ratio, yeah, sure, you can add some details here on the curvature as well, just to have more details. More details is usually better. So this is now a exportable 3D model. So you can now export this as a STL file. Nice. So jumping into another software that is more commonly used for polygons, I'm going to show you the reason why we have polygons. So polygons are more or less the standards within 3D formats to export it or to display it, because a polygon is, so I need to show you the polygons. So you can see here the lines on the models. I can control them, add some details and so on. So for example, I'm going to make 2 boxes here. So sorry, I just lost myself there. So triangles are more commonly used to, for example, map things. So if you have, let's say in a visualizations program, you have a carpet or you have a wall or something that bends. So how do you try to project a flat map or a texture, let's say a wooden texture or something, onto something that is curvy? That's really, really complex, and you need to divide the smooth surfaces into polygons to be able to map something like that. So let's say here that I'm gonna convert this to a polygon model. I'm not really gonna show you exactly everything here because I don't think that's interesting. I'm just gonna make, so you see here that I can define the different setups of polygons. You can see how the result actually is getting smoother as I add more details. So if I had just like 3 details, I have a much lighter file, but I don't have any smoothness. So for example, in this case, if I want to map this with a texture of some sorts, I'm just going to do this really quickly, hopefully speed it up for you. And doing something like this. Now, I've now tried to map or to project a pattern on these models. So you can see here that it actually stretches a little bit. So you see this polygon is good, but this one is too tall. Also this pattern. So on the flat surfaces, they are mapped from the beginning. So those are pretty easy, but this surface needs to do, we need to do something about that. So I'm just going to show you these tools. I'm not going to teach you them because I don't think it's interesting for you. But the goal here is to select all of these surfaces, for example. And you can see here that it's more or less projected a flat model here. So this plane here, that's the 2D image. So we imagine that we now project, let's see, I think that's more or less perfect. So you can see now from this angles, everything is almost completely flat, but that's not realistic. I mean, if I change my face, now everything is stretched over here. So the goal here is to show you these models here. So these are the polygons that we're talking about, and you can use tools like relax, and you can start to relax this and it will stretch in the right order. So if you didn't catch that, as you see now, it has a little bit of a rectangular shape, and as soon as I start relaxing it, it will stretch out. So that means that when I now look at this, these polygons are more or less the same size, or sorry, the boxes here are more or less the same size however I look at it. So instead of using this plane now, we've actually stretched these files to represent the curvature of the model. So without going too deeply into UV mapping and everything, the reason of using polygon is to be able to control that stretch more or less. So you want to be able to add details, but also remove details. So if you have a scene full of, let's say, car parts, that's going to be an amazing amount of details and math just to explain that this bolt has an infinite amount of circles within it, and you have then a million screws in a car. So that's just way too much data. And also, polygons are good for when you more or less want to just create models quickly. So you can do this rough shape, almost like you do with the shapes. So I'm gonna just control this here. You can see that I can also get it inside, so there's no volume in here. It's just surfaces and triangles. I should be able to actually show you the triangles. Somewhere. Yeah, so you can see the triangles, how they actually explain that model. But anyways, this is usually good tools to do visual models, because you can, as you do with the surfaces, you can control the flow better. And also you want to do that, you want to be able to select surfaces, edges and draw stuff. You can also use like smoothing tools here to smooth this, and in the same way as we do with the surface models, we can control the flow by changing and adding stuff. So we add details and so on. So this is also a good way if you want to sculpt. You can use tools like ZBrush to convert all of these polygons and start to sculpt them and create details that way. So just to summarize, the polygons are usually what you do want to do when you do visualization and 3D models. So for example, you want to light something up, or you want to use something to create a 3D scene for I don't know, for rendering and stuff. Let's see if this works. Yeah, so you can do the renderings and things like that. So that's what polygons are mostly used for by artists. By designers and mechanical engineers, you want to be able to create a flow. So in this case, in a polygon model, there's no way for me to go back here. I can't go back and edit these. As soon as I jump down and want to edit, I remove the details of the mapping that I just did. So there's no way for me to like reset this and add or subtract the amount of polygons here. I can do it in some complex ways, but there's no easy way for me to let's say just add the radius here. So I have to, if I want to do that, I have to move all of these. So I'm just going to select them. And I have to try to like scale them over, and that usually doesn't work. Yeah. So it's a real hassle as soon as you do something wrong with polygons. With surface models, you can of course just go back and edit the parameters, which is really cool. So let's have the fillet here. I just want to change that to 4 millimeters instead. I can do that. So with solids and surface models, so surface models are like a bridge between organic polygon modeling to more mechanical engineering. So what you can do with solids is, let's imagine that you're a designer, you're supposed to 3D print something. You want to have the ability to go in and change measurements like this. Let's say that the CNC operator wants you to add some details because he can't something, his tools doesn't work. He needs you to add 0.5 millimeters, 0.05 millimeters, just so that his machine works. Then you can do that. You can't do that in polygons on that precision level. So that's why you have solids. And usually you take, let's say you do rendering or you want to show a product. You can of course do rendering within Fusion 360, and it's pretty okay. But when you want to do more photorealistic rendering, you need to work with polygons. You need to work with big scenes, create grass, create textures, add wood, light, and everything like that. And those things work much more easier with polygons. And with that said, I think that I've managed to give you some clarity, but also confuse you when it comes to polygon. They're like polygons are like pixels, and solids are like vector graphics, and surfaces are like tangents on a surface. Tangents on a vector graphics. Hope that makes sense. And if you have any further questions, please just drop them below, and I'll try to answer them as good as I can. Okay, so the last question is, which one is best? Well, that totally depends on your application. So for surface organic modeling, you can see on the left side we have a surface model. So it's much easier to control a smooth shape versus controlling all of these shapes. On the right side, we have more or less a polygon model. So if I want to create the same shape, I need to edit all of these control points to get a similar result. So if I just drag one control point up, I will get a sharp triangulated extrusion here, or a movement, so to say. So also with that said, this grid here, if I would zoom in on that grid, I will still I would get just sharper edges. There won't be any more resolution. But on the surface models and solids, I don't have the same resolution. So almost the same as a pixel image versus a vector image. It doesn't matter how far you zoom, you will still have the same mathematicals explaining the edge. But with pixels or triangles, which means mesh, as soon as I zoom, I will start to see the underlying structure of a round shape. So as I showed you with the solids, with the mesh when I convert it, the triangles on a rounded model will be much worse to look at when I zoom in. So I'm just going to show you here quickly again. Something like that. So a rounded edge here will soon be just flat. There won't be enough details. So that's more or less how that works. Also, when it comes to polygons, they are much better to work with when it comes to, for example, modifying, animating, rigging. So in this case, if you want to control, let's say, a movement, it's much easier to control a few polygons than to control an infinite amount of math, which would be a solid or a surface model. So you don't animate surface models. You create a polygon version of it with the resolution that you want to. Let's see, this is quite a low polygon, and then you smooth it. So you do the control before you smooth it, and then you have a smooth model that you can control with the easy bone structures and so on. So mesh models are more for game visualization and so on, but they're also a product of a solid model. So you can take a solid, you can convert it more or less into STL file, OBJ, and so on, and use it for polygon applications. So I hope that clears a little bit out where to use it and how to use it. So for my viewers, you're mostly 3D print orientated, so you want to use something like solids or surface models and then export into a mesh format for the printer. I will probably see printers taking the solid formats in the future as well, but that's the whole goal. If you want to create some more, let's say, polygon 3D prints, if you want to create these kind of shapes, it's usually easier to model these with let's say, a polygon modeler instead of solid tools. So for example, this one is kind of complicated, and these ones are as well to do in a solid software. It's almost easier to just create a low poly version in 3D Studio Max or similar softwares directly. So low poly modeling are easier to do with polygons instead of solids.
So that's all for this video. So I hope you enjoyed it. I hope you learned something. Hopefully everything that's like solid surfaces, everything that's that very complicated is hopefully much more clear now. If you enjoyed the video, please click like. If you have any questions, drop me a comment. Let me know if there's anything else you want to see like within these formats. So thank you very much. Have a nice evening, night, day, and I'll see you later. Bye.